Good morning, everybody, and welcome back to Next Door NetAdmin. So we've gone through and created a Windows image, cleaned it up, and that's cool. Something else I found out while we were doing that was that there's a way to load Windows PE via PXE. If you're not sure what PXE is, PXE stands for Pre-Boot Execution Environment, which is a fancy way of saying you turn on the computer, and instead of booting from a local disk, such as a USB drive or a CD or the local hard drive, whatever you want to call it, it could be an SSD. Instead of booting from any of those, it can boot from the network. But in order to boot from the network, it needs to have the basic network services such as DHCP, and it needs to understand how to communicate on the network. That's what pre-boot execution environment is, and that's all it is. All it exists for is to get an IP address and then boot off of the network. I'm not going to go into full detail on how that process happens, but basically it has to get DHCP. DHCP has to provide the correct options to tell it where to get its boot files. And then it needs to download those boot files via a protocol called TFTP, which is Trivial File Transfer Protocol. It's called trivial because it's really simple to implement and execute in code, so okay, fine. But once it does that, it downloads its boot files and uses them to start up so that it's running off of something it downloaded from the network. And that means it's not touching any of the local disk files, and you don't require a USB stick or optical media in order to boot the machine. It can just come straight off the network. So that's kind of cool. I'd only known how to do a Windows PE, which again is pre-installation environment. I only knew how to load that from optical disk or USB drive because that was all the instructions that I had seen from Microsoft. But then I found instructions on how to do this for PXE. And it's a wonderful thing. So let's just jump right into it and I will show you what I was able to figure out. So we start and it's exactly what it says. Configure a PXE server to load Windows PE. It's even pretty much up to date. This was just February last year, 2023. That means it should work, right? No, it doesn't work. Of course it doesn't work. I don't know why I expected that it would off the, at least on the first try. So here is what the story is with that. There's two ways to load a computer. Two ways to boot it up. There's your standard BIOS, which is what we always refer to it, but there's the legacy BIOS specification, and then there's the newer BIOS, what we call BIOS, which is actually UEFI. UEFI has very different requirements for loading files and executing them in a pre-boot environment than BIOS did. So as it turns out, these instructions are specifically for BIOS environments, which you can sort of replicate if you've got UEFI by turning on the Compatibility Support Module, or CSM. But I want to be able to boot it in UEFI directly, particularly because virtual machines in Hyper-V, if it's Generation 1, it uses BIOS. If it's Generation 2, it uses UEFI. And only UEFI. It doesn't have a compatibility support module that can kind of let it do both. And if you install it using Generation 1, if you install an operating system using Generation 1, you can't go back later and move it to Generation 2 without essentially re-imaging the whole machine and changing the boot files, which is a pain in the rear. So for maximal usefulness and efficiency, I wanted to make this load using UEFI. That took me a couple of hours to figure out. So I'm here to share that with you so that you can get this going if you wanted, with a lot less headache than I had to go through. This does say that it applies to Windows 10. It works for Windows 11. It's fine. And in fact, I'm going to set it up using Neither of those. I'm going to use boot files from Windows Server 2022 / Windows 11. It works for both. They use the same boot files, so it's fine. Prerequisites: a deployment computer with the Windows Assessment and Deployment Kit installed, or the automated installation kit, the Windows AIK. It's the same thing I've shown you before. A DHCP server, a PXE server, a file server. These can all go on the same machine. Perhaps not the deployment computer, but these are all on the same machine. And in fact, I'm going to show you a program that I use that combines DHCP and PXE into a single executable. And the reason for that is kind of important, but we'll get to that later. Step 1, copy the Windows PE source files. I'm not going to do that because I already have a Windows PE boot environment set up. I don't need to copy it fresh. It's going to tell me to mount the boot.wim. I've already done that, and here it is. Cool. It's already been mounted. There's my boot.wim. Fine. Map a network share to the root TFTP directory. I'm going to skip that for now because I'm just going to show you what files we would be working with, and then I'll go over there and show you everything that I have set up. So under mount, it's going to go Windows boot PXE. Copy all of those. Okay, well, so that's Windows boot PXE. Cool. It wants me to copy all of these. Wonderful. So you'd copy all of those to the share. But here's the catch with that. You see these N12 files. They're the boot files that you would expect for BIOS. And when you go through the rest of this how-to on Microsoft's website, that's what it's going to tell you to use. But the file you actually need is not in here. I still copied the whole thing, so you'll see all of these files on my PXE server. But none of these files are being used directly. Not directly. Yeah, and this is, yeah. So that's that. Then you need to copy the boot.sdi file here. In my case, I've mounted my ISO file for Windows PE. That's fine. And I should have checked. It's under the boot folder. Yeah, okay. So boot.sdi, that needs to be copied over as well. And then the boot WIM needs to be copied over, which is under sources, right there. And then, if you want, and I generally do want, you copy over the boot fonts directory as well. And that just has all of the extra boot files, boot fonts for rendering all the various languages that it can support. Cool. So you copy all of those over to the other server. Then you need to start working on your BCD. Boot configuration data store. It's a single file. It's in binary registry format. And it's just a matter of creating it. So I'm actually going to copy these various commands into a new text file so that we can review all of these commands and just keep going from there. All right. Don't need that. Do want that. And then the last one is these. Okay, cool. Now, we can see that there's a whole bunch of stuff that needs to be replaced. And I'm actually going to start by saying I want all of these not to work directly on the C drive. I want to have this work on I want to have it work in the temp directory just because that's going to be a little cleaner. Cool. All right, so that's replaced all of those. Wonderful. Let's start with the very first command. This has all the stuff that's left over from previously, so I'll just clear that. There we go. All right, so we're going to create the new boot store. All right, fine. These RAM disk options are all going to just start configuring things that we're going to use later. The interesting thing is this create the WinPE boot image. WinPE boot image in this case is going to return a GUID. Cool. This is what we need to replace all of these GUID ones with. So I'm just going to do that really quickly here. And this one as well. There we go. Now we can run the rest of these commands. I'll add another carriage return there just so that we can do that. But before you copy all of this, there's one other little thing you need to be aware of. This path, Windows System 32 winload.exe, and you can see that here, C Windows or mount Windows System 32 boot winload.exe. That is the file that you need for a BIOS boot. For a UEFI boot, you actually need to call winload.efi. It's in the boot.wim that you already copied over, so you don't need to worry about adding it per se, but you do need to update this to winload.efi instead of winload.exe. And then we will do the rest of these commands just like that. There we go. And if we proceed to do a bcd edit store c temp bcd enumerate all, it tells us exactly what we've set up. There's a Windows boot manager. Cool. Here's the Windows bootloader. It's going to boot off of the boot.wim using RAM disk options, which are down here. It's going to reference the boot.sti that we copied over. Cool. And it's going to load winload.efi rather than winload.exe. And that's the key part in the BCD that we need to have set up. And then this particular BCD file is just a single file. So that gets copied over to the share as well. Now, the other thing I mentioned, you remember I said that it's going to have us reference, if you go down here and look at the PXE boot process summary, it's going to reference PXE boot.n12. But that is the BIOS boot file, and we need to get a UEFI boot file. The UEFI boot file is actually in our ISO, and it's located at EFI boot bootx64.efi. You could call it bootx64.efi when you copy it over to your PXE server. You don't have to. I have renamed that, and I will show you that in a moment. But because a standard name for this, when it's in the Windows/System32 directory, the standard name for this is actually bootmgfw.efi. Boot manager firmware, I guess, .efi. Cool. It's renamed in an ISO because UEFI boot spec requires that it be named bootx64.efi and it be stored at /efi/boot if the computer is booting from the default path. Now, we don't need to keep it named that way because part of what we're doing is DHCP tells you exactly what boot file name to use. So if we configure DHCP to pass the parameter for bootmgfw.efi, that's what the computer will download and run. And then we don't need to worry about understanding what this file is or where it came from. It's using the standard name that Windows has. Cool? Clear as mud? That's fine. So let's go over and take a look at the deployment server, or not deployment server, excuse me. Let's have a look at the server that I have set up for DHCP and PXE. If we take a look here, we'll see I've got DTFTP. This is where my TFTP root is. And there's the boot directory that Microsoft's instructions tell us to create. In here, I have all of the files that I copied, including this PXE boot.n12 that doesn't work for what I want it to do. I copied bootx64.efi and made it bootmgfw.efi. So that's there now. And I have my boot.sdi, my bootwim, and my bcd file that I created previously. Cool. I also have the fonts directory. Amazing. What do I do with this? Well, once it's on the disk, cool. I have tried using the Windows DHCP server for this. It didn't quite work the way that I wanted it to. And the reason for that seems to be that in the Windows world, you contact DHCP, it gives you a bunch of options, and then in my mind, you take that option and you just go and use TFTP to download it. But in the Windows world, apparently, it wants to do some proxy DHCP work, and so it'll try and contact the server on port 4011 as well before it starts doing TFTP to try and negotiate some additional options. If you're just using Windows DHCP, it doesn't know that it needs to provide those options, and so that port's not open. If you're using Windows deployment services, that's a lot heavier than I want to go into. It would take care of that along with DHCP, but I don't want that. So I decided, okay, in that case, I'm not going to use the Windows DHCP server at all. I'm not using Windows deployment services. I don't care. Instead, I'm using a little utility program called TFTP64, and that might be a little difficult to see. So let me start this up. It used to be called TFTPD32 because it used to be 32 bits and now it's 64. This is the service edition, so I actually have it installed as a service and it'll run in the background pretty much all the time. But this little program will do a bunch of things. It can do TFTP, it can do syslog, it can do DNS. For this, all I want it doing is TFTP and DHCP. On the TFTP side, I just set the base directory. It used to have option negotiation checked like this, but I need to use this for PXE. So when I click that, it automatically deselects option negotiation. As long as you have PXE compatibility, that's good. DHCP, I've said, okay, I want it to be this IP address pool, fine. I've given it the boot file name of bootmgfw.efi. Standard DNS servers, it doesn't really need a WINS server. I didn't put that in there, so that's something that it's added on its own. Fine. I don't mind too much about that. But that's all that you need to set up. If it's got a boot file, it knows it's using itself as the boot server, so you don't have to worry about all the other options. It will send option 60 to indicate that it is a PXE client capable server. It will send option 66 with its own IP address. It will send option 67, which is this one for the boot file name. It'll take care of all of the rest. So when you have this running, if you PXE boot your station, it will connect and it will boot correctly off of this. What'll that look like? Well, how about I show you? All right, now we're on the other server where I have my trusty Windows 11 builder machine turned on. All right, first thing that I'm going to do in this case is say I don't want to boot from a file, I want to boot directly from the network and actually have this boot off of our PXE server. So then, when I click Start, and it'll think about it for a minute. There we go. So now it's starting PXE over IPv4. It gets an IP address, and then it starts downloading the boot.wim file. This will take a little bit of time, so let's fast forward. And there it goes. And now that it's downloaded that boot file, it can go ahead and get started in Windows PE. And that's not done yet. So we're just going to knock that out. And there it is. So with that, I can turn that off now. Now I've shown you how you can fairly easily take a Windows PE boot disk system and make that available via PXE. Microsoft's instructions are a good start, but they aren't complete for UEFI. But now you know how to make it complete yourself. So hopefully that was interesting and useful to you. If you have any suggestions for things you'd like me to cover or any questions about what you've seen today, feel free to let me know down in the comments. But until next time, thank you very much for watching. I am your next door NetAdmin, and we'll see you next time.